let's do some problems from page 137 in our book. Number 19, a regular pentagon is inscribed in a circle whose diameter is 24 centimeters. All right, let's draw a picture. Got a nice little circle. Diameter is 24 centimeters. That means our radius will be 12 centimeters. Well, there's a regular pentagon inscribed in here. Well, let's try and draw a pentagon. Now, a regular pentagon just means that the sides and the angles are all congruent. We need to find the length of the side. So a side right here, something. I'm going to draw another radii from center out to the edge of the circle. And this is going to be 12 also. They might be tempted to say, hey, that's a right angle. We can start using some trig functions right now, but we can't, with the amount of trig that we know right now, we can't find the length of this side just yet. Well, it'd be really helpful if we had this angle. Well, if I drew some more triangles here, I'd have 5 of these triangles so that this angle would be 1/5 revolution of this whole circle. So 1/5 of 360 degrees, which would be 72 degrees. So that's kind of neat, but with our trig functions, we need a right angle. Well, let's make a right triangle. Let's drop an altitude down here to this side. Now we have a right angle. It just so happens that this angle, 72 degrees, has been cut in two, so this angle, this little triangle right here, is 36 degrees. Now, if we know that this side length is 12, this angle is 36 degrees. Now, if we just use a sine function, we can figure out the length of this opposite side, double it, and that's the length of the whole side of the pentagon. All right, so sine of 36 degrees, our known angle, is equal to the value x, which we don't know yet, over 12. Therefore, x equals 12 sine of 36. Well, 12 sine of 36 is approximately equal to 7.0534, and keep going on. But we don't really need this value, so I'm going to leave it stored in my calculator. I'm just going to multiply this value by 2 because 7 is approximately the length of this side, but I want the entire thing. So I want 2 times this length, so take that distance times 2. So therefore the side length is approximately equal to 14.1068 centimeters. All right, let's go to another one of the more difficult problems. Diameter of a planet is taken to be 7,912 kilometers. What's the distance from the farthest point to the surface visible from the summit of a mountain 1 kilometer in height? All right, looks like we're working with the planet again now. So let's draw a planet. All right, and so the diameter is 9,000 or 7,912. So our radii will be 3,956. All right, and then we want to see surface visible 1 kilometer in height. So if this is not drawn to scale, say we're at a mountain and you're standing on top of this mountain, you're looking off into the distance, into the horizon, and then you can see one spot visible, the farthest spot you can see visible. Well, that's from your line of sight back to the planet or the earth or whatever, that's going to be a nice tangent line. What do we know about a tangent line to a circle and a radii? They're perpendicular. So right here we have a right triangle. Here's a side, here's a side, here's a side right here. Okay, this is a radius, 3,956 kilometers. This distance right here, this hypotenuse is 3,956 plus 1 kilometer. So basically, we have a triangle, right triangle, with side length 3,956, side length 3,957. We just need to know this side length, which is your line of sight from the top of the mountain back down to the planet. Looks like we have three sides. Two of the three sides, we can use Pythagorean theorem to calculate this missing side. So x squared plus 3,956 squared equals 3,957 squared. Do the calculation. X equals the square root of 3,957 squared minus 3,956 squared. Use the old calculator. All right, now we get the decimal approximation to be about 88.955 kilometers. Okay, finally, do one more problem. Here's a lighthouse 44 meters above the sea. Here's our awesome drawing of our lighthouse. 44 meters above the sea. The angle of depression to a buoy out here in the sea is 18 degrees, 30 minutes. Well, there's 60 minutes in degrees. This is 18.5 degrees. Find the horizontal distance from the buoy. So we want to know this distance right here. All right, if you're standing up here in the lighthouse and you're talking about the angle of depression, that's the angle down from horizontal. So there's horizontal looking straight across from where you were at on top of the lighthouse. And the angle of depression would be looking down to the buoy. So this is my line of sight right here. This is the angle of depression, which is 18.5 degrees. Well, if I copy my height of the lighthouse over here, I now have a right triangle. 44 meters right here. We have an angle, and we want to calculate this distance, which is the same as this distance right here. Well, it looks like we have set up something with the tangent function because we have the opposite and the adjacent side. We have an angle. So therefore, we'll write up a little tangent function here. The tangent of 18.5 equals 44 over x. Now solve for x, you get x equals 44 divided by tangent of 18.5, and obviously that's in degrees. 44 divided by 5. And we get the decimal approximation of about 131.5 meters.